Welcome students. Now we are going to learn sp hybridization. Atomic number of carbon is 6. Its electronic configuration in ground state is 1s2, 2s2 and 2p2. In excited state, one electron from 2s atomic orbit migrates towards 2p atomic orbit and the electronic configuration becomes 1s2, 2s1 and 2p3. There are 4 unpaired electrons in outermost orbit, out of which one is present in s atomic orbit and other 3 are present in p atomic orbits. Before bonding, hybridization takes place. In case of sp hybridization, there is mixing of one s and one p atomic orbital takes place, and after mixing 2 sp hybrid orbitals are formed. Number of atomic orbitals mixed are equal to 2. After mixing, number of hybrid orbitals formed are also equal to 2. That is 2 sp hybrid orbitals are formed. These are p atomic orbitals which not take part in process of hybridization. That p atomic orbitals are known as unhybridized p atomic orbital. Thus, sp hybridized carbon, this is sp hybridized carbon, and that contains 2 sp hybrid orbitals containing single electron and 2 p atomic orbitals containing single electron. That is, out of 4, 2 are present in sp hybrid orbitals and 2 are present in p atomic orbitals. These are atomic orbitals and the shape of p atomic orbital is dumbbell shape. Therefore, these are the shape of p atomic orbitals, while these are sp hybrid orbitals. And to minimize electronic repulsion, that sp hybrid orbitals orient in space having angle 180 degree. That is, there is a linear shape and the angle is 180 degree. When compound contains carbon triple bond carbon, at that time that carbon is of sp hybridized carbon. Now we will see formation of acetylene. Acetylene, its IUPAC name is ethine. The formula is CH triple bond CH. In acetylene, both carbon atoms are in sp hybridization state, and we know that sp hybridized carbon have 2 sp hybrid orbitals and 2 unhybridized p atomic orbitals. These are p atomic orbitals. Similarly, that carbon also have 2 sp hybrid orbitals and 2 unhybridized p atomic orbitals containing single electron. Now, first we see how carbon triple bond carbon is formed. Out of triple bond, one bond is sigma bond and other 2 bonds are pi bond. When sp hybrid orbitals of these 2 carbon atoms axially overlap, this is axial overlapping of sp hybrid orbitals of carbon, and after axial overlapping sigma bond is formed. These unhybridized p atomic orbitals, they are laterally overlap. There is a lateral overlapping of p atomic orbitals and pi bonds are formed. Thus, there are 2 pi bonds and 1 sigma bond. Carbon triple bond carbon is made up of 1 sigma and 2 pi bonds. Sigma bond is formed by axial overlapping of sp hybrid orbitals and pi bonds are formed by lateral or sidewise overlapping of p atomic orbitals. This is formation of carbon triple bond carbon. Then in acetylene there are 2 CH bonds. sp hybrid orbital of carbon axially overlaps with s atomic orbital of hydrogen. and this is also sigma bond. Similarly, sp hybrid orbital of this carbon axially overlap with s atomic orbital of hydrogen, and this sigma bond is formed. Thus, in acetylene there are 3 sigma bonds and 2 pi bonds. In acetylene there are 3 sigma bonds and 2 pi bonds. Carbon sigma bond is formed by axial overlapping of sp hybrid orbitals of carbon. Carbon hydrogen sigma bond is formed by axial overlapping of sp hybrid orbital of carbon and s atomic orbital of hydrogen. And carbon-carbon pi bond, there are 2 pi bonds. Carbon-carbon pi bond is formed by lateral overlapping of p atomic orbitals. In case of acetylene, the shape of the molecule is linear. Shape of the molecule is linear as sp hybrid orbitals orient in space having angle 180 degree. Therefore, the shape of the molecule or structure of the molecule is linear and the bond angle is 180 degree. Shape of the molecule is linear and bond angle is 180 degree. This is formation of acetylene. Now, we see the summary of sp3, sp2 and sp hybridization in short. Carbon atom is in 3 type of hybridization state. One is sp3, sp2 and sp hybridization state. These are the 3 hybridization state of the carbon. When carbon atom is in sp3 hybridization state, carbon single bond carbon is formed. That bond is of the type sigma bond. That carbon single bond carbon is of the type sigma bond. The orbital overlapping is sp3 hybrid orbitals of 2 carbon atoms. That is, when sigma bond is formed, there is axial overlapping of sp3 hybrid orbitals of 2 carbon atoms. The shape of the molecule is tetrahedral and the bond angle is 109.28 degree. In case of sp2 hybridization, carbon double bond carbon is formed, and out of that 2 bonds, one is sigma bond and another is pi bond. Carbon-carbon sigma bond in sp2 hybridization, it is formed by axial overlapping of sp2 hybrid orbitals, and pi bond is formed by lateral overlapping of p atomic orbitals. The shape of the molecule is planar and the bond angle is 120 degree. When carbon atom is in sp hybridization state, at that time carbon triple bond carbon is formed, and carbon triple bond carbon is made up of 1 sigma and 2 pi bonds. Sigma bond is formed by axial overlapping of sp hybrid orbitals, while pi bonds are formed by lateral overlapping of p atomic orbitals. And when there is a sp hybridization, the shape of the molecule is linear and the bond angle is 180 degree. Another point I am going to discuss, when there is a sp3 hybridization, then what is the percentage of s character? There are 4 orbitals involved, 1s and 3p. Total contribution of orbitals is 100%. 100 divided by 4, that is equal to 25. In that case, sp3 hybridization, the percentage of s character is 25%. In case of sp2 hybridization, 100 divided by 3, and there is only one s atomic orbital, therefore, its percentage of s character is 33.3%. While in case of sp hybridization, there are 2 orbitals involved, therefore, 100 divided by 2, that is equal to 50, and there is one s and one p atomic orbital, therefore, percentage of s character is 50%. Thus, from sp3 to sp hybridization, percentage of S character increases, and as percentage of S character increases, electronegativity of carbon increases. And this is the summary about hybridization of carbon.